My name is Edward Thompson. I'm a program manager for Microsoft Visual Studio Team Services, and I focus on Git and version control. I'd like to introduce you to a technology called GVFS. It's the Git Virtual Filesystem, and it's a tool we've created to allow Git to handle enterprise-scale repositories. We created this technology within Visual Studio Team Services. VSTS is Microsoft's platform for software developers. We support the entire software development lifecycle, beginning with planning and ending with deployment to your servers. Part of this, of course, is hosting your Git repositories. Of course, we don't just host your Git repositories, we also use VSTS ourselves within Microsoft as the platform that hosts our own projects. And that includes truly enormous projects like Microsoft Windows. So building support for handling these large Git repositories was a team effort between the Windows team at Microsoft and the Visual Studio Team Services engineers. The result is GVFS, which extends Git to support enterprise-scale repositories like the Windows codebase. To give you a sense of scale for what we mean when we talk about large repositories, let's take a look at the repository that most people think about when they talk about a large repository, the Linux kernel. The Linux kernel is big. When you check it out, it's about 600 megabytes on disk, and it consists of about 57,000 files. But as far as enterprise-scale repositories go, that's really not all that large. Within Microsoft, if we look at my Git repository, the VSTS repository, it's much bigger. Checked out, it's 3 gigabytes on disk and 110,000 files. But as far as repositories that we need to support, that's just the tip of the iceberg. The Windows repository is the biggest Git repository on the planet. When you check it out, it's 270 gigabytes on disk, 3.5 million files, and it has 4,000 people working on it on a day-to-day basis. The Windows repository is what we measure all our scale by, and naively, Git doesn't work in the Windows repository. It needs GVFS. If you simply put the Windows code into Git, it takes about 12 hours to clone it, 3 hours to switch branches, and status takes 8 minutes just to tell you that nothing's changed. Trying to add a file and commit it takes 30 minutes. So it's obvious that Git cannot handle the Windows repository alone. By itself, Git scales very poorly to large code bases like Windows, and it does two things that are particularly problematic. First, it downloads all the files in the repository, including all of the history. That's what happens when you run git clone. In fact, that's why Git calls the command clone. You get a full copy of the repository, including all the history. And in a very large project, that's very time consuming and it takes up a lot of disk space. It just doesn't scale. The other problem that Git has is that many Git operations scale with the number of files in the repository. And again, if you have 3.5 million of them, like the Windows repository does, things take a long time to execute. Simply too long for us to wait. And that's why we built GVFS. GVFS is a team effort between the Visual Studio Team Services team and the Windows team, and it allows Git to operate without major changes to the repository. You don't have to split the repository up into chunks, and you don't have to use a technology like submodules. You can simply put all your code into a single Git repository with GVFS. And GVFS handles both of the scale problems for large repositories. First, instead of downloading every file when you do a clone, it only downloads the files you need as you need them. You get the repository structure first, and then you page in, on demand, the files as you access them. Second, it enables a technology within Git called sparse repositories, and it manages the sparse repository configuration for you. That means that Git operations will only consider the files that have been accessed through GVFS, and with many operations, only the files that you've actually modified. When we apply these changes to the Windows repository, we get that clone time down to just 90 seconds. You can start working in this huge repository in only a minute and a half. If you want to switch branches, that now takes 30 seconds, down from 3 hours before. Status now takes 8 seconds. And that's still slower than we want it to be. We're still making improvements to GVFS, but that 8 seconds is a significant improvement from the 8 minutes that it took without GVFS. Commit now takes 10 seconds, 5 seconds to add a file to the index, and 5 seconds to actually create the commit. Most of this speed comes from what we call the GVFS filter driver. In a typical development scenario, you have an application like Visual Studio or like a build tool actually talking directly to the NTFS file system. And of course, all the files that you're building have to be on disk. Well, with GVFS, they don't. GVFS introduces what's called a filter driver. And this filter driver produces a view of the repository that doesn't actually exist on disk. So if you look on disk, you appear to have these files, but in fact you don't. Not until you actually access them. And when you open the file with, let's say, Notepad or a build tool, let's say you open file number 2, the GVFS driver intercepts that open call, and it asks the Git server, in this case, Visual Studio Team Services, for the content. Once you've downloaded the content, it returns it to the program that asked for it, and it actually saves it on disk so that the next time you open the file, you don't have to go back to the network. If you were to open file number 5, the same thing happens. So the file content is actually downloaded on demand. Let's take a look at what this looks like in practice. Here, I'm going to use GVFS to clone a repository. This is just my open source project, libgit2. Libgit2, to be honest with you, isn't really all that big. It's certainly not as big as Windows or VSTS. It's not even nearly as big as the Linux kernel. But I want to clone it for 2 reasons. Even though I don't need GVFS for it, I think this is helpful to illustrate that GVFS works with any Git repository without any changes. You don't need to do anything special to use GVFS. You can just start using it. The other reason I'm using it is because it's nice and small and I can clone it very quickly for this demo. So you see when I did clone it that it says that it's fetching commits and trees. This is important to how GVFS works. Commits and trees are what make up the repository structure. They're the Git objects that show how a Git repository is laid out on disk. What we didn't download are the blobs. Those are the actual files in the repository. So right now we have the information about the repository structure, but we don't have any of the files themselves. However, I can go into my repository, go into the source directory and run dir, and I actually see these files. So this is the GVFS filter driver projecting the repository's structure, even though we don't have these files. It appears that we do. And I can even type one of these files. I can open up the file and read its contents. And what happened when I did, you might have noticed a split-second delay. It actually downloaded this file from Visual Studio Team Services, put it on disk, and then opened it and typed it to the console. And if I do that again, you can see, if you notice that split-second delay, that's gone. So I'm actually reading the file off disk now, so it's much, much faster. I can also use Windows Explorer or really any application to navigate through my repository. And all these files appear to be on disk, even though they are not. Now what I want to do is actually open up Task Manager and find the GVFS driver, find GVFS itself and kill it. So we can take a look at what is actually on disk without GVFS running. Again, GVFS is presenting that view of the file system. Now that we've killed it, we don't have that filter driver. We can only see what's actually on disk, what's actually been downloaded. So if I go back to my command prompt and now I run dir, you see that I don't actually have that much. I can look within the repository and within the tests directory. You can see the copying file and you can see some stuff that might have gotten paged in from Windows Explorer navigating through. So again, the copying file was what I ran type on so that we could actually see the contents. So now if I rerun the GVFS filter driver, I can start it again on the console and I can print debugging output to the console. You see that last line is virtual repo is ready. That means GVFS is actually ready to go. And so now I can go back with Windows Explorer and open up one of these files and watch in the debug console as I do. I'm going to open with Notepad. You can see at the bottom line of my debug console, it says that it's downloading loose object and it gives the object ID. That's the actual blob ID, the Git object ID of this file that we opened, write.c. This wasn't on disk already, so it's gone to Visual Studio Team Services. It's downloaded that, it's paged it in on demand, and now it actually exists on disk for the next time. Let me open up another file and you can watch as it happens. I'm going to open up this one. Let me open up one more and watch the debug console at the bottom as I do. It's now downloaded that loose object too. So it's downloaded these 3 loose object files on demand. It's paged them in. So this is how GVFS brings in files on demand as they're actually needed. So that's part of the GVFS story. That's what's reducing the amount that gets downloaded when you clone and when you fetch. The other part is, again, what we call the sparse checkout file. And that's what instructs Git to not look at everything within the repository. Let's take a look at that. If I navigate into my source directory, I can look at this .git folder. This is the actual Git repository itself. This is the data. This is where information about branches lives, and we can open up the info directory. And then there's this file, sparse checkout, and I can open that. And now you can see these are the names of the files that have actually been paged in. Those are those 3 files that we just opened, the 3 that were downloaded, and of course the config file from earlier. This is what actually instructs Git to pay attention to only these files that GVFS knows that we've opened. GVFS updates this file automatically. Git will then read it, and that's how it can limit the scope of its work to just the files that we've examined. So these 2 optimizations taken together, the limited downloading when you fetch, as well as the automatically updating the sparse checkout file, are what allows GVFS to handle enterprise-scale Git repositories. To keep up to date and to get more information about GVFS, visit the GVFS website at gvfs.io. And if you're interested in learning about the scale challenges that inspired GVFS, as well as other changes to Git, visit visualstudio.com/git-at-scale.